Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. What is the correct order of heat of combustion of above compounds? This 3, 1, 2 and 3. So what is the correct order? 4 options are given. I request everyone student please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. Don't worry, after some time you'll have the right answer with proper explanation. So let's start. Before going to the details, we should know what is heat of combustion. Heat of combustion means actually standard enthalpy change. Obviously the condition is standard, so the enthalpy change or energy change when 1 mole of one particular substance is burned in presence of excess oxygen such that complete combustion should be achieved. And during this condition, how much energy change, or you may say, sir, how much energy is released. Okay, that's the heat of combustion. Look at here. This reaction, for example, this is actually cyclopropane. By the way, if I say alkane, that is CnH2n plus 2. Remember, for cycloalkanes, the general formula is CnH2n. Do not get confused. That's a structure is just formula is right or wrong. Even sometimes this question they can ask that this cycloalkane and alkene, they have general structure, common structure. Now C3H6, if you want to burn it completely, one molecule, by the way, since 1 mole written, we'll focus here. So 1 mole. Now here it produces 3 carbon dioxide and 3 water. So obviously it will release energy. Similar thing for butane, 4 carbon dioxide, 4 water. For pentane, 5 carbon dioxide and 5 water. This is the thing. Now this reaction is exothermic. Now you may ask one question, sir, why it is exothermic? So for that purpose, if you look at these in this reaction, it produces stable molecules like carbon dioxide and water. So during this reaction, from a comparatively lesser stable molecules to more stable molecules is produced. So obviously it will release some amount of energy, and that's why all these 3 reactions are exothermic. Okay, now one very important thing, how could I understand that which of my hydrocarbon will emit more energy or release more energy and which will release less energy? Obviously you can think very easily. Number of this CO2 and water produced by the complete combustion of 1 mole of hydrocarbons. Okay, now if you look at in case of propane 3 and 3 6, in case of butane it's a 4 and 4 8, so obviously more. So you may expect, sir, compared to propane, butane combustion or 1 mole butane combustion will release more energy. Yes, even in case of pentane that is even higher because 5 and 5. So from these I can conclude that maximum energy will be produced by the combustion of pentane, after that butane, and minimum will be by propane. So what is the order? 3 greater than 2 greater than 1, 3 greater, yes, option C is the right answer. Okay, so if you get this question, student, in your exam less than 30 seconds, how could you solve? You need to understand you are burning a hydrocarbon producing more stable molecules like water and carbon dioxide. That is the reason these hydrocarbon produces energy. So obviously more the number of CO2 and water production, more will be the energy release. So that is the order. Even remember, recall one theory that we said diesel is more powerful fuel than gasoline or petrol. Why? Because diesel nearly 20 carbon containing hydrocarbon, whereas petrol may be octane 8. So diesel has more number of carbon. So upon combustion of 1 molecule or 1 mole diesel, it produces more amount of CO2 and water, which produces more amount of thrust, or you may say which releases more amount of energy. That's why the more powerful car engines are majorly diesel based. Okay, by the way, what is your opinion? Do you have any other logic? Please write in the comment box. I want to know. Okay, so in conclusion, what we've learned today, that heat of combustion indicate the maximum amount of energy released upon complete combustion, very important, and that is only possible if excess of oxygen there. Okay, so 1 mole of hydrocarbon, if you burn completely, how much energy is released? And higher the value of heat of combustion indicate the more powerful fuel. Okay, and this data of combustion is very helpful for the calculation of stability of any fuel or organic molecule. Why? Because you have taken 3 different hydrocarbons, but if your final product is same like carbon dioxide and water, from that thing you can calculate which one is comparatively more stable and less stable. By the way, in this construct you can say, sir, is a C3 3 carbon, 4 carbon, 5 carbon, so that may confuse. Yes, in order to eliminate that confusion, you may take per carbon energy release data. Means whatever energy release you get from here, divide by 5, here by 4, and here by 3. So from that you can conclude, or you can calculate, okay, which of the hydrocarbon is comparatively more stable and less stable. Okay, so this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.